Hello, welcome back to our next video for Chapter 5, Practice Problems. So picking up where we left off in number 11. And in this problem here, we're trying to, based on a probability, it's a binomial distribution probability, and at the very end here, we're trying to find the probability that fewer than 3 of the selected adults visit their primary care doctor first for a high fever. Given this, that we know that we're looking at 3 individuals that we're looking at with a probability of 0.08, we have a total population of 7 adults. So when we write this kind of off the side, if you're never really sure where to start with, start putting things you do know on the side. So the probability of fewer than 3 individual adults, so we know that's going to be our x value of 3. We know our n is equal to 7, and we have a probability equaling to 0.8. So now we have these off to the side. We want to find the probability of fewer than 3 selected, right? So we want to know that fewer than 3. So what is less than 3? Well, 2 is less than 3, 1 is less than 3, and 0 is less than 3. 3 is not less than 3, so we wouldn't include that. We're just finding the probabilities of finding 0, 1, or 2 individuals out of these 7 that won't go visit their primary care doctor first for a high fever. When we do this, we're going to have to set up 3 binomial distribution problems where our x is 0, equal to 0, and our x is equal to 1, and our x is equal to 2. And remember, our binomial distribution function is n, c, and I'm going to put x, and your calculator has an r value, right? P to the x power, and then times q to the n minus x power. And we're going to have to do this for 3 times for, once again, for when x equals 0, when x equals 1, and when x equals 2, and then add those probabilities all together to get what is the probability of finding fewer than 3 of these 7 adults that were selected. So when you do this off the side here, I'm going to kind of write. So when you do the probability of 0, when x equals 0, here you get a probability that's equal to 1.28 times 10 to the negative 5th. And then when we do x equals 1, that's going to equal 3.5 times 10 to the negative 4th. And x equaling 2 is going to equal 4.3 times 10 to the negative 3rd. And we would just add up all these probabilities, and when we add them all up together, you're going to get a value at c, and that tells us the probability of finding fewer than 3 adults. So moving forward now, we're going to be using this next table in front of us where we have where it states here, it's a probability distribution. So it's not a binomial table because, right, the probabilities are now changing in between. And when we're trying to find the mean of a probability distribution, our probability of the mean is, you can find these formulas on page 185 in your book. And so mu, remember, the mean is equal to the sum, or sigma, times x, or the sum of x times the probability of x, and you add them all together. So when you break this down, x times the probability of x, so 0 times 0.05, 1 times 0 is 0. 1 times 0.19 is 0.19. 2 times 0.32 is 0.64. I think you get what we're doing here. We're just multiplying x times then the probability, so 0.48, then 0.40, and then 6 times 0.03 is 0.18. So now we have multiplied x times the probability of that x value, and now we're going to sum them. So we're going to add all these values up, and when we add them up, you get 2.52. So when we're asking what is the mean probability of this offspring distribution, we'd say it's 2.52. When we're finding the standard deviation for it, if you look at our book, once again on page 185, you can see the formula for standard deviation. There are a couple different ways to do the formula for standard deviation. You can follow the book. Another one that I use, because I think it's a little simpler, is you're taking the sum of your x value minus your mu, and you're squaring it, and then you're multiplying that by the probability of x at that value, and then you sum all those values together, and then take the square root of it, because this is truly the variance, and take the square root of it to get your standard deviation. The book has a different example, but what really one of the better ways to do it, just to help avoid confusion, is to use your graphing calculator, where you're making your list 1 all of the x values, and then make your list 2 all the probability values that are associated with x there. So here you would make this like a list 1 and make this your list 2. And then when you go and run one variable statistics that you may have been doing for your mean and standard deviation, instead of just putting list 1, you put list 1 and list 2 for there, and you'll get the mean and standard deviation of a probability distribution. Or you can follow these formulas that are found in the book or right here. When you do this, and no matter how you do it, you're going to get a value where the standard deviation, sigma, is equal to 1.417. Number 14, when we're trying to find the probability of exactly 3, since the probability is already given to us at 3, we just look at what the value of 3 is. So it's 0.21. That is the probability of finding exactly 3, because it's already given to us. Number 5 is the probability of more than 3. So when we're looking at more than 3, well, 3 is equal to 3, but we want more than 3, so we're looking at 4, 5, and 6 as our x values. So we're just going to add up these values right next to it. When we add all those values up, we're going to get 0.23. And once again, just to show how this is all working, anytime you see expected value or mean or average, we're finding the mean. They're all synonymous with the same thing. So we already did that up at number 12, and you just copy down the same answer. That's where that value is. Moving right along to number 17. So these next ones are very similar, all the same. We're just getting a value of n and our p-value and finding, what is our expected number, our average, and then what is the standard deviation. Remember, an average or a mean is equal to n times p, and our standard deviation is equal to the square root of n times p times q. So when we write out what is the expected value here after reading on it, your n value is 10, 10. And then your probability is 0.24. So average number, expected number of houses to see is 2.4. Do the same thing for standard deviation here. We're going to take our n times p times q, right, and get our, I'm going to take the square root. So if you take, one second, I'm going to do, if you take your 10 times 0.24 times 0.76. Remember, q is the probability of failure, or 1 minus p. Take the square root of these values, you get 1.3506. Moving on to number 18, expected value again. So we have 13 as our total number of n times our p of 0.14, and it gives us 1.82. What is standard deviation here now? And that's going to be the square root of 13 times 0.14 times the probability of q of 0.86, and that equals 1.2511. And then moving on, like I said, all these ones are doing the same thing as far as the very first part. What is the expected number here? So we're going to take 6 as our n times 0.26, which is our mean, 1.56. Standard deviation is going to be 6 times 0.26 times the value of q, 0.74, square root of that, and you get 1.0744. Now we get into the next part here for our binomial distributions and try to find what is the probability between 2 and 4. So when anytime you have a problem like this, we're just finding what is the number that is between 2 and 4. Well, if we write that 2, 3, 4, it's just 3. We're looking for 3. If we wanted to know what was the probability between 1 and 4, well, there's 2 and 3 between 4, so we're looking at the probabilities of 2 and 3 added together. It's just the numbers between. It's never, think of 2 and 4 as these bookshelves, and we want to know just about the book. We don't care about the bookshelf. So between 2 and 4, we're just looking at the value of 3. So our x value we're looking at is 3. So we're going to write our binomial distribution, where we have n is 6, so how many different ways can we choose 3 people out of 6, times our probability of 0.26 to the third power, times our q, which is 0.74 to the n minus 6, which is also going to be third power. Anytime you're doing exponents, don't put in 6 minus 3 is the exponent. Just put the value of 3. If you're trying to do this individually, each section individually, that's fine too. If you put it all in the calculator together, make sure you just you have your parentheses in the right place. When you do this out, you should get a value that equals 0.1418, or about 14.8% was the probability of x equaling 3, or the probability between 2 and 4 respondents with this behavior. Okay, I'm going to stop there, and then we'll pick back up with number 20 and the rest of the packet. I'll see you all in the next video.